काल जो जूट आना था वो आया?
हाँ सर, 16 बिल आए टोटल।
अच्छा,
आपका ग्रेडेड TD3, TD4, TD5।
अच्छा अच्छा।
Ever since the 18th century, no other agricultural crop has had as big an impact on Bengal's industry as jute.
वेट वगैरह देख लिया था?
अलग-अलग करके सबको दिया था।
हाँ देख लो, वो पहले।
Primarily composed of cellulose and lignin, this bast fiber has renewed its importance because of its reasonable cost of production and biodegradable properties. The National Institute of Research on Jute and Allied Fiber Technology, or Nirjaft, is a 7-decade-old institute in the southern fringes of Kolkata. Nirjaft has been developing technology on the usage of natural fibers since its inception in 1938. The institute later became a constituent unit of the Indian Council of Agricultural Research, or ICAR. Nirjaft functions from 4 different divisions on research and development, such as quality evaluation and improvement, mechanical processing, chemical and biochemical processing, and transfer of technology. These divisions work in unison to develop and disseminate jute-based technologies.
Scientist of this institute is working for quite some time to develop new technology, new process, new production system for diversified uses of jute. And one of the production system modification is the preparation of jute bonded fabric, which we call non-woven fabric. And this has got a very good potential, and it will open up a new avenue for bulk use of jute. It can be used as automobile interior, composite substrate, filter material, maybe thermal insulation, sound insulation, and many other packaging, floor covering, or handicrafts.
A fabric made up of jute fibers can be woven or non-woven. While a woven fabric is made by interlacing fiber threads, a non-woven one is obtained by fiber web formation, stacking the layers one above the other, and random entanglement or bonding of the fibers.
You see here 2 sets of threads are there. One is these threads widthwise, and another is the longitudinal. These 2 threads are there. But in non-woven, there is no such concept, no threads at all. From fiber, we are making the fabric. First we make the fiber sheet, and then it is entangled or bonded by some means. It may be mechanical by needling, or maybe chemical by using some adhesive, or maybe thermal. If thermal, then we have to use another fiber, synthetic fiber with jute in some proportion, like 15 to 20%, so that it is a low melting fiber and it can melt with the application of heat.
This is the non-woven wing of the mechanical processing division. A non-woven fabric is being made in this needle punching machine. Here, the jute is almost separated into fiber. But that needs to go through certain processes before it turns from the mass of closely stuck jute fibers into this loose quality. Supplied by the vendors, these bales consist of long strands of fibers. Commonly known as reeds, they constitute fibers which adhere in a meshy structure. The reeds are now sprayed with batching oil water emulsion. The adding of this oil water emulsion makes the jute soft and helps retain moisture, which is essential for good processing. Now they are put into this softener machine, which further breaks the rigid and compact structure of the fibers. Contrary to the woven system, the processes leading to a non-woven fabric are far lesser in number and require a substantially lower production cost. The long reeds are arranged on this inclined conveyor belt or ramp of the carding machine evenly. Here, the reeds are stretched and broken to obtain the fibrous entity. This is a sliver, and it is used as feed material in the needle punching machine. Now let us go back to the needle punching machine. Fiber lumps from the sliver are arranged evenly in the feed conveyor of this card. The fiber mass is separated while passing through these rollers. Here, the fiber web is the first step towards the formation of a non-woven sheet. This is what is known as cross-lapping. It leads to the formation of a manifold web. Cross-lapping is followed by this needle punching loom. Here, a layer of fibers is seen entering this chamber and getting entangled by the needle barbs. Each needle has these barbs narrowly cut into its interior and is protruded outside. The needles move vertically up and down to entangle the jute fibers with the barb. The process yields a fine mat of jute non-woven. The technology of forming such a non-woven mat is what Nirjaft has been promoting for years.
I think jute non-woven is the future of jute. What is needed is you need certain products which can consume bulk quantity of jute as it is done for sacks. So this non-woven agrotextiles, this is a huge market. Even whole jute produced in India will be wiped out if a certain fraction of agricultural land starts using agrotextiles. So we call it jute non-woven is the future of jute.
Funded by the National Jute Board under the Jute Technology Mission of the Ministry of Textiles, Government of India, the institute has commissioned a project on non-woven technology. Under this project, low-cost jute non-woven fabrics are developed and used for agro-horticultural purposes. But this precedes a thorough checking of the material at Nirjaft's testing laboratories. Some fabrics have been sent for checking their tensile strength.
Here we can see the extension versus tenacity. So this is an instrument normally used for measuring the tensile property of the fabric. Specifically, the tensile strength, its extension to break is an important property for the non-woven fabrics when it is used for its industrial application or agrotextile or its geotextile. So the material, how much load it can hold, or for a given load how much extension it will take before it break, that can be measured by this instrument.
Besides, a test of air permeability lets us know how much air the fabric allows to pass through. This is particularly helpful to assess a mulching cloth.
For jute processing, the important part is the needle board and the parameter of the fabric parameters. Say fabric parameters here, the fabric weight, type of fiber we are processing, length of the fiber, fineness of the fiber. So these are the parameters influence the fabric properties.
Nirjaft is making non-woven material from other natural fibers like banana, sisal, hemp, rami, flax, coir, and their blends with synthetics to a lesser extent. The needle-punched non-woven fabrics are used as filters, decoratives, floor coverings, mulching cloth, horticultural pots, substrates of composites, and in many other areas, including automobile interiors. There are, however, other methods of making non-woven jute material. Now we are at the workshop of the adhesive bonding machine. Here, the fibers are cut into pieces and then fed to the Midhurst opener. Inside this machine, the fibrous mass is almost reduced to short individual fibers. It acts as the feed material for the Callaghan adhesive bonding machine. This machine comprises a hopper feeder, 2 randomizers, an impregnator and a dryer. Put into the horizontal lattice of the hopper feeder, this loose fiber mass is passed through an inclined lattice and an evener lattice. This forms a thick and even sheet of material. Inside the randomizer, the opener separates the fiber mass into single fibers. The fibers are then deposited on the cage. The caged section has a perforated roller with suction from the inside. Driven by air current, the fibers stick to the holes of the rotating cage. As the roller rotates, the holes go behind the suction unit where there is no inward air pressure. This loosens the stuck fibers from the holes and allows them to be carried away over the conveyor belt. This happens twice in 2 randomizers before being carried to the impregnator and drying section. Nirjaft uses a laboratory model to reduce excess use of adhesive. Now, this fabric can be used as